Audio's API uses things a specific way, so these declarations of functions have a specific argument, and all of those arguments are in order, in a certain order, and they're also, some of them are pointers, some of them are not pointers, so there's different ways we're going to use them. And that's because Apple's API needs to do different things, and I'll show you what this one does in a minute. So the first argument, audio graph, we can simply reference the value of our audio graph. We're just going to directly get the value of it. And we do that by saying audio graph exclamation, because we know there's a value there. We know it's not nothing anymore. We created the audio graph above, so we know we can use that exclamation now to unwrap that value and get it. And then you want to make sure you have a comma. And then second argument is going to be our component description variable that we just created. And this one is a pointer in the declaration, so we need to use that ampersand symbol to reference that. And then finally, another comma. The last argument is our output node, and you want to use another ampersand to reference the pointer to our output node. And then finally, after we do this, we can write the number 1 on our output node. Because if we just have two AU nodes, those values above to those synth node and output node properties, those are the same value. They're 0 at first. But after we run this create output node function, it assigns that output node the number 1. It's as simple as that. And now we know what our output node number is. It's always 1. So now we can know what's our output node. It's the piece of paper with 1 on it. Now up above, we're going to go back to our init audio function. Pretty simple. All we do to run our create output function node out there is we just do create output node parentheses. There we go. We call the function. Everything's done for us. And good news, guys. We're doing something similar next. Now what we're going to do is we're going to go below to our create synth node function, and we're going to create another audio component description. Now this one, the component type and component subtype are going to be different. The component type is going to be K audio unit type music device. That's our music device, our synthesizer, our piano, magical. And then the next one is a MIDI synth. This is an appropriate place to introduce what is MIDI. MIDI stands for Musical Instrument Digital Interface, and it's one of the most important things in the music technology world. It's what allows us to have electronic instruments like this that try to mimic real instruments as closely as possible. For example, I play a note on this electronic piano, and it sounds like a piano, or at least it tries to sound like one. And I can play it really soft or really loud. And that's because MIDI has a property called velocity, which we'll talk about a little bit later. But MIDI is very important because instead of having an acoustic device, we can have a sound bank of pre-recorded sounds, also known as our sound font, and we can use MIDI to access each sound from that sound bank. So we get different notes. And that's why MIDI is important in this case, because MIDI transfers the sounds in numbers, and those are our note numbers. So this might be C4, and this might be C5, which is just an octave higher. So it knows the note number, it knows the octave, and as I discussed earlier, we can play it soft or hard. So back to our code, we have a component type of music device, we have a subtype MIDI synth, and the manufacturer is still Apple because we're still creating this for the iPhone, or we're using one of Apple's audio units. And then the component flags mask, still 0. Don't worry about that right now. And then at the bottom, we have our check error function. And again, all we're doing here is we're checking for errors when we run the AU graph add node function. And same kind of deal here, our audio graph. exclamation point, because we know that there's a value there and we're safe. We're good to go. Swift is going to unwrap that for us. And then we use ampersand to reference to our audio component description for our synthesizer audio unit. And then we also reference to our synth node, where we're adding the audio unit to. And after this, you'll see that our synth node, that blank piece of paper, we add it to the audio graph, and now we give it the number 2. And that's what it might look like in the code, just to verify for you guys. I was kind of curious at how it works, so I did some stuff on my own to figure it out. And now we also go back to our init audio function, and we call our create synth node function. And then after that, we can go ahead and run another function, check error again, and inside that we're going to run another function, graph open, which is going to open our audio graph for audio processing. So go ahead and graph open, and then inside that, again, we just unwrap the value of the audio graph. And then after that, we're going to run another function, check error, and this is going to return some info about the nodes that we just added. And first argument is our audio graph, the graph that we're adding the nodes to. Second argument is our synth node, and now that we created the node, we don't need to reference it. And then the third argument is actually the out component description. We're just going to leave that nil because we're not using that right now. And then finally, this is the important part. This is where we actually give the info of our synth audio unit. We give that's a place to hold that audio unit, right? That we just got. We just created that description in the create synth node function. Now we're going to give that description to our audio unit. So we directly reference the audio unit, synth unit, and you want to make sure you have that ampersand because that's going to reference it. And now we can add that synthesizer, remember that OP1 that I have? We can add that to the graph now. And that represents that we now have added all of our nodes, and we've added our audio units to our nodes as well. Now that we got the nodes and audio units set up, we need to connect them all together, obviously, to create an audio chain where we can process that audio straight to our speakers for the device. And how we're going to do that, we're going to create 2 new constants, the synth output element and the IO input element. And we create these constants by putting the word let. Instead of var, you use let whenever you're declaring a constant. And then both of these elements we're going to set equal to 0. And you're probably wondering, what is an audio unit element? Well, literally, it's just a number that describes something inside the audio unit. But the element itself, I'm going to draw a picture of what an audio unit looks like as a whole so you guys can picture this. So what I'm going to draw right now is the IO unit, the input-output audio unit, which is a very common audio unit that Apple uses. So the IO audio unit has 2 scopes, just like most audio units do. It has the input scope, basically its left side, and the output scope, basically its right side. And both of these scopes will have these little dots on it, which are connection points, or elements, if you will. And element 0 on the left is the input, and element 0 on the right, top right, is the output of element 0. And these 2 dots at the top go to the device's speakers. And the bottom 2 dots, on the other hand, are element 1, and those take input from a device microphone. The synth output element, on the other hand, 0 does not just mean the output of the synth. This means we're connecting the synth as a whole audio unit, to our IO unit. And this is confusing because element 0 in some cases can also mean you're using the global scope, which means the audio unit as a whole. But this confusion, don't let it get in the way. It just means we're connecting all of our synth unit, all of the elements of that, to our output unit. But the only thing we need to use in our output unit is element 0, because all we want to do is get our audio to the speakers.